After more than 40 years, the Voyager 2 spacecraft has crossed the boundary that marks the start of interstellar space.
For decades, NASA believed Voyager 2's greatest discoveries were already behind it. Then, from billions of kilometers beyond the planets, the aging spacecraft transmitted signals that challenged long-standing theories about the edge of our solar system. Built in 1977 and expected to operate for only a few years, Voyager 2 has continued exploring the unknown long after anyone imagined possible. As its power slowly fades, every new transmission carries the potential to rewrite what we know about interstellar space and may become one of the final messages humanity ever receives from its most distant explorer. The spacecraft that refused to die. On August 20th, 1977, a rocket lifted off from Cape Canaveral carrying what many believed would be a routine planetary mission. Hidden inside was Voyager 2, a spacecraft designed to explore the outer planets before its power inevitably ran out. Engineers expected the mission to last only a few years, ending once it completed its flybys of the giant worlds beyond the asteroid belt. No one imagined that nearly half a century later, the same spacecraft would still be talking to Earth from the edge of interstellar space. Voyager 2 launched during one of the rarest moments in modern astronomy. The giant planets had aligned in a way that happens only once every 175 years. This extraordinary arrangement allowed a single spacecraft to use the gravity of one planet to slingshot toward the next, dramatically reducing travel time and fuel requirements. It was a once-in-a-lifetime opportunity, and NASA designed one of the most ambitious robotic missions ever attempted to take advantage of it. The gamble paid off beyond expectations. The success of Voyager 2 was never guaranteed. Every planetary encounter demanded extraordinary precision, with flight controllers calculating trajectories years in advance. A tiny error during a gravity assist could have sent the spacecraft drifting away from its next destination, ending the mission prematurely. Instead, each successful flyby increased Voyager 2's speed and redirected it toward another unexplored world. These carefully executed maneuvers transformed a single mission into one of the greatest journeys in the history of space exploration, proving that careful planning and engineering could extend humanity's reach far beyond Earth. As Voyager 2 swept past Jupiter, it revealed details scientists had never seen before. It discovered previously unknown moons, studied enormous storms raging across the planet's atmosphere, and transformed our understanding of the largest world in the solar system. At Saturn, it uncovered new structures within the planet's magnificent rings while providing close observations of several icy moons. Then came the missions that no spacecraft has repeated to this day. Voyager 2 became the first and still the only spacecraft to visit Uranus and Neptune. At Uranus, it uncovered a bizarre planet rotating on its side, surrounded by faint rings and an unusual magnetic field unlike anything previously observed. Years later, at Neptune, it captured breathtaking images of violent storms and supersonic winds, revealing that even the most distant giant planet was surprisingly active. By the time Voyager 2 completed its planetary tour, it had transformed countless scientific theories into direct observations. The mission had already exceeded nearly every expectation placed upon it. Yet the most remarkable chapter was only beginning. Instead of shutting down after Neptune, Voyager 2 continued traveling outward, leaving the familiar planets behind and entering a region where no human-made spacecraft had ever collected data. With every passing year, its power supply slowly weakened, and engineers knew difficult decisions lay ahead. Instruments would eventually have to be switched off one by one to keep the spacecraft alive. Even so, Voyager 2 refused to stop. Decade after decade, it continued sending faint radio signals across billions of kilometers, surviving far beyond its intended lifespan. What began as a planetary explorer gradually became humanity's first long-term observer of the distant frontier separating our solar system from the rest of the galaxy. That lonely journey toward the unknown would soon produce Voyager 2's most astonishing discovery. one that challenged decades of scientific predictions about what truly exists beyond the sun's invisible frontier. Beyond the edge of the solar system. For decades, scientists believed they understood where our solar system ended. The sun constantly releases a stream of charged particles known as the solar wind, creating a vast protective bubble called the heliosphere. Beyond that invisible boundary lies interstellar space, a region dominated not by our sun, but by the galaxy itself. According to long-standing theories, the transition between these two environments was expected to be gradual, almost peaceful, as the sun's influence slowly faded into the surrounding cosmos. Voyager 2 revealed a very different reality. On November 5, 2018, after traveling for more than 41 years, the spacecraft crossed the heliopause, becoming only the second human-made object ever confirmed to enter interstellar space. Scientists eagerly awaited the data, expecting it to confirm decades of carefully developed models. The implications reached far beyond a single scientific breakthrough. Researchers suddenly had real measurements from a region that had existed only in computer simulations and mathematical models. Every new transmission helped scientists compare theory with reality, revealing that the boundary surrounding our solar system is constantly shaped by changing solar activity and the conditions of interstellar space. Rather than being a fixed border, it appears to be a dynamic frontier that expands, contracts, and evolves over time, making Voyager 2's observations increasingly valuable with every passing year. Instead, the spacecraft delivered one surprise after another. Rather than drifting across a calm boundary, Voyager 2 encountered what appeared to be a compressed, turbulent region where the solar wind collided with material flowing through interstellar space. Its instruments detected a sudden increase in plasma density, suggesting that the edge of the sun's influence was far more abrupt than researchers had predicted. Even more astonishing were the temperatures. Measurements indicated conditions reaching tens of thousands of degrees Kelvin, far hotter than scientists had expected in one of the emptiest regions surrounding our solar system. Instead of a quiet frontier, Voyager 2 found a dynamic environment shaped by powerful interactions between the solar wind and the galaxy beyond. The discovery forced researchers to revisit long-held theories about how our solar system interacts with interstellar space. These findings extended beyond scientific curiosity. Understanding this boundary is essential for planning future missions that may one day travel even farther than Voyager. Any spacecraft leaving the heliosphere must pass through this unpredictable region, making Voyager 2's observations invaluable for the next generation of deep space exploration. Yet this wasn't the first time Voyager 2 had challenged accepted science. More than 3 decades earlier, during its historic flyby of Uranus, the spacecraft had detected radiation levels so intense that scientists struggled to explain them. The reading suggested an environment unlike anything observed around the other giant planets, creating a mystery that remained unsolved for nearly 40 years. Because no spacecraft ever returned to Uranus, those measurements became the foundation of scientific understanding. Researchers debated countless explanations, but none fully accounted for the unexpected intensity of the radiation belts. Only recently did a possible answer emerge. Scientists now believe Voyager 2 may have arrived during an unusually powerful solar wind event. Rather than observing Uranus under normal conditions, the spacecraft may have flown through a temporary burst of energetic particles that dramatically intensified the planet's radiation environment. What appeared to be a permanent feature may instead have been the result of extraordinary space weather occurring at exactly the wrong, or perhaps the perfect moment. The discovery carried an important lesson. Space exploration often relies on brief encounters separated by decades. A single snapshot, no matter how remarkable, may not tell the whole story. Voyager 2 reminded scientists that the universe is constantly changing, and even the most trusted observations must remain open to new interpretation as fresh evidence emerges. Today, that realization has renewed interest in sending another mission to Uranus, where modern instruments could determine whether Voyager witnessed an extraordinary event or only uncovered part of a much larger mystery. One thing, however, is beyond debate. Time and again, Voyager 2 has revealed that the universe refuses to behave exactly as we expect. Every major milestone in its journey has replaced certainty with new questions, proving that exploration is not about confirming what we already know. It is about discovering how much remains beyond our understanding. As Voyager 2 ventured deeper into the darkness beyond the planets, another challenge quietly grew inside the spacecraft itself. It was no longer distance that threatened the mission, but time. Keeping Voyager 2 alive. Distance is not Voyager 2's greatest enemy. Time is. Every system aboard the spacecraft depends on electricity generated by 3 radioisotope thermoelectric generators, commonly known as RTGs. Instead of solar panels, Voyager 2 relies on the heat released by slowly decaying plutonium to produce power. It was an ingenious solution for deep space travel, where sunlight becomes far too weak to generate meaningful energy. But nothing lasts forever. Since its launch in 1977, the spacecraft's power output has steadily declined. Each passing year leaves NASA with less electricity to operate its scientific instruments, communication systems, and onboard computers. The mission has gradually become an exercise in survival, forcing engineers to decide which parts of the spacecraft can continue operating and which must be sacrificed forever. Every shutdown is permanent. When an instrument is switched off, it is unlikely to ever operate again. That means every decision carries enormous scientific consequences. Turning off one experiment may preserve the spacecraft for several more months or even years, but it also means losing data that can never be collected again. The challenge has become increasingly difficult. To extend the mission, NASA engineers have searched for every possible source of usable energy. In an extraordinary display of creativity, they identified a small reserve of backup power that had originally been set aside as a safety margin decades earlier. Although it was never intended to support scientific operations, engineers realized the mission had already entered the kind of emergency that reserve power was designed for. Using that hidden reserve bought Voyager 2 valuable time. The additional energy allowed critical instruments to remain active longer than expected, delaying another shutdown and extending humanity's ability to study interstellar space. It was a remarkable achievement, but only a temporary one. There is no second reserve waiting to be discovered. Every remaining watt now becomes more precious than the last. As Voyager 2 continues its journey, the list of active instruments grows shorter, narrowing the amount of information the spacecraft can still send home. Yet even with fewer scientific tools, every transmission remains unique because no other spacecraft is exploring the same distant region. Maintaining communication has become another remarkable achievement. Because Voyager 2 is now so distant, its radio signal reaches Earth incredibly weak, requiring NASA's Deep Space Network to detect transmissions that are barely distinguishable from background noise. Commands sent from Earth take nearly 20 hours to reach the spacecraft and another 20 hours for its response to arrive. Every conversation with Voyager 2 unfolds across almost 2 days, demanding patience, precision, and complete confidence that every command has been carefully planned before it begins its long journey into deep space. Then, just when the mission seemed stable, another crisis nearly ended everything. During what should have been a routine communication sequence, Voyager 2's antenna shifted only 2 degrees away from Earth. On a nearby satellite, such a tiny movement would hardly matter. But Voyager 2 is not nearby. Separated from Earth by billions of kilometers, A 2-degree misalignment was enough to break the communication link completely. Suddenly, the spacecraft that had faithfully reported its discoveries for decades fell silent. For NASA's engineers, it was a nightmare. Without a reliable signal, they had no immediate way of knowing whether Voyager 2 had suffered a catastrophic failure or was simply pointing in the wrong direction. The only option was patience. Engineers transmitted powerful commands using the Deep Space Network and hoped the spacecraft's automatic protection systems would eventually restore the antenna to its proper position. Days passed. Then, at last, a faint signal returned. Voyager 2 had successfully realigned itself, re-establishing contact with Earth and avoiding what could have been one of the most heartbreaking endings in the history of space exploration. The recovery demonstrated not only the spacecraft's remarkable engineering, but also the foresight of the teams who designed its autonomous safety systems nearly 50 years earlier. That incident served as a powerful reminder of just how fragile this extraordinary mission has become. Voyager 2 is no longer simply exploring deep space, it is surviving it. Every signal received today represents the combined efforts of generations of engineers who continue finding ways to keep a half-century-old spacecraft operating far beyond anything its creators originally imagined. Yet even if its final transmission arrives tomorrow, Voyager 2 has already secured a place in history. Because beyond the science, beyond the engineering, and beyond the discoveries, it carries something far more enduring than data alone. The message that will outlive humanity. One day, Voyager 2 will fall silent. Its power will eventually drop below the level needed to operate its transmitter, ending one of the longest-running conversations between humanity and a machine. There will be no dramatic explosion, no final farewell, and no rescue mission waiting in the darkness. The signals will simply stop. But Voyager 2's journey will not end. Long after its electronics fail, the spacecraft will continue drifting through interstellar space at incredible speed, crossing the galaxy for millions of years. Unlike the civilizations that built it, Voyager 2 may survive for an almost unimaginable length of time, silently traveling through a universe that continues to evolve around it. Yet perhaps its greatest cargo is not scientific equipment. Attached to the spacecraft is one of humanity's most remarkable creations, the Golden Record. More than a scientific experiment, it is a message from Earth. Inside the gold-plated disc are greetings spoken in dozens of languages, music from cultures around the world, images of human life, and recordings of Earth's natural sounds. Ocean waves, birds singing, wind moving through forests, and even the heartbeat of a human being were carefully selected to represent our planet. The record was never intended to solve scientific mysteries. Instead, it was created as an introduction. If another intelligent civilization were ever to discover Voyager 2, the Golden Record would offer a glimpse into who we were, a species driven by curiosity, creativity, and the desire to understand the universe around us. It reflects not only our scientific achievements, but also our art, our cultures, and the shared experiences that define humanity. Whether anyone will ever find it remains unknown. The chances are extraordinarily small, yet that uncertainty has never diminished the record's meaning. Its true value lies in what it says about us. Rather than sending only technical information into deep space, humanity chose to send music, languages, laughter, and the sounds of home. That decision transformed Voyager 2 into something greater than a spacecraft. It became a time capsule. Even after every instrument has stopped working, Voyager 2 will continue carrying that message through the galaxy, preserving a small piece of Earth long after today's civilizations have changed, or perhaps disappeared altogether. The mission has already rewritten science. It revealed hidden moons, explored worlds never visited before, challenged accepted theories about Uranus, and fundamentally changed our understanding of the boundaries separating our solar system from interstellar space. Built with technology from the 1970s, Voyager 2 achieved discoveries that continue influencing modern research nearly 50 years later. The impact of Voyager 2 reaches far beyond the discoveries recorded in scientific journals. Its mission proved that bold ideas backed by careful engineering can achieve what once seemed impossible. Every milestone encouraged future generations to think beyond the limits of existing technology and imagine missions capable of traveling even farther into the unknown. Universities continue to study its data. Researchers still publish new analyses based on its observations, and mission planners frequently reference its accomplishments when designing the next era of deep space exploration. Few spacecraft have remained scientifically relevant for so many decades, and even fewer have continued expanding humanity's understanding of the universe long after their original mission was considered complete. More importantly, its influence extends beyond the discoveries it made. It continues to inspire the people who will shape the future of space exploration. Voyager 2 has also inspired a new generation of scientists and engineers. Many of today's planetary missions were designed using lessons learned from its remarkable success, from spacecraft durability to long-distance communication and mission planning. Its discoveries continue to influence proposals for future expeditions to Uranus, Neptune, and even interstellar space. Although newer spacecraft carry more advanced technology, Voyager 2 remains the benchmark for endurance, reminding researchers that a single mission can continue producing valuable science long after its original objectives have been completed. Its greatest lesson, however, may be far simpler. Exploration does not end when a mission reaches its original destination. Sometimes the most extraordinary discoveries begin only after every expectation has been surpassed. Voyager 2 was never supposed to become humanity's longest-serving explorer. Yet by refusing to give up, it has shown that persistence often leads to the greatest breakthroughs. Somewhere beyond the planets, beyond the sun's protective bubble, and far beyond the reach of any future rescue, Voyager 2 continues its endless voyage into the unknown. And with every kilometer it travels, it carries a reminder that humanity's greatest strength has never been knowing all the answers, but having the courage to keep searching. Nearly 50 years after its launch, Voyager 2 continues to inspire the world by proving that curiosity can outlast expectations. Its discoveries have reshaped our understanding of the solar system, while its journey reminds us that the greatest adventures often begin beyond the edge of the known. As it drifts silently toward the stars, Voyager 2 carries humanity's story into the cosmos, a lasting symbol of exploration, hope, and the endless pursuit of knowledge. Thanks for watching.